projections and least squares. The next point in this chapter is projections and least squares. When we are unable to solve Ax is equal to b, when it has more number of equations than unknowns, then the methods we need to follow have to be different, and we are going to discuss that one. So for example, let's say there is a matrix which can give us the equations as 2x is equal to b1, 3x is equal to b2, 4x is equal to b3. Then the solutions of this exist if this b1, b2, b3 are in the ratio of 2:3:4, and we may not be able to find the exact value in many of the such cases. So what is the method to be followed in those cases when number of equations are more than the unknowns? Here only one unknown is there, but we have 3 equations corresponding to that. So in these kind of cases, in these situations, we need to go for the least squares. So the most common convenient average come from sum of squares. So for all this, the solution, the value of x has to be solved by using the squares method, the sum of squares method, so which will be represented by e square. So let's see what is there here. So 2x minus b1, we'll write this first equation by taking this b1 on the left side. Similarly, the second one and third one, these all are summed. And the thing is, if there exists an exact solution, if there is an exact solution, means if exact value of a is present, then the minimum error e is 0. In more cases, b is not proportional to this, b is not proportional to these a's. So the graph of e square will be parabola when we draw this e. When we draw this a and b, then it would be a parabola, and the minimum error is at lowest point where derivative is 0. So let's see how the things have to be done over here. dE square. So let's do the differentiation of this one to find out the value of this error, or let's find the value of this x. When we differentiate, we know this is square, so it becomes 2, and as the power is 2 in all these equations, we take this 2 outside, so it can be written as 2 into 2x minus b1 will be the differentiation, and with x there is 2, so we'll write 2. Here there is 3, we'll write 3, and here 4 is there, the same thing, is equal to 0. So the minimum error is at lowest point where derivative is 0, and we need to find that value. So solving it for x, when we solve this one for x by equating it to 0, it indicates that which will be a minimum value, minimum error point. The least square solution of this model system x is equal to b is denoted by x cap. So least square solution, we refer it as, so the least square solution, that point is referred as x cap, is equal to, now by solving this we'll get 2b1 plus 3b2 and 4b3 at the numerator, and on the below, and in the denominator we get these values. And if we see our a is 2, 3, 4, so we have that 2, 3, 4. So A transpose, because this is in the column space, and now we have this one in the row space. So 2 plus 3 plus 4. So we can write this one as A transpose, and with those the b's are multiplied, so A transpose B it is, and this is just A square. So we can write this one as A transpose, A's values A. So when row and columns are multiplied, we know we get the same things. So we solve this Ax is equal to b by minimizing. E square is equal to ax minus b the square. So we'll get, depending upon the number of terms in A, we'll get it is a1x minus b1 plus a2x minus b2, that square. Then similarly last one would be ax minus bm the square. The derivative of e square is equal to 0 at the point x cap if this all works out to be 0, means the same solution is this, ax is minus b. Here we are writing it as, it is for a particular this problem, and generally e square is given in what way is being written. It is a x minus b the square, and we have written it as 2x minus b1. So 2 is our a1 and this is our first value of, that is b1. So a1x. So generally it will be in this form, and the derivative of this one has to be 0 at the minimum error point. And E is what? E is the distance from B to the point AX. E is the distance between the B and AX in the column space. The error vector, so the error vector will be there. The error vector means the distance. Error vector is B minus AX, means this error E is nothing but the distance between B and AX. How can we write it? We can write it as the small e is equal to B minus AX cap. So this E should be perpendicular to the column space. Whatever this error vector is there by the theory, because we are getting AX minus B, this is square, means it is just like the length of our perpendicular or orthogonal vectors. So in case of orthogonal vectors, we have seen that the A transpose A or X transpose Y is equal to 0, means when they are multiplied we are getting 0. So similarly here AX cap minus B1 is our error and A1 is the column space, and as the result has to be 0, this indicates that the error vector E must be perpendicular to the column space. Then by this we have some predictions. To solve these kind of problems, the predictions are: the first one, all vectors perpendicular to column space. All vectors perpendicular to column space lie in the left null space. So from the theory we know that all vectors perpendicular to column null space, all vectors perpendicular to column space are have to be the left null spaces. So the same theory of orthogonal vectors is being again reused, or it is used to solve this. So all vectors perpendicular to the column space lie in the left null space. This indicates that thus the error vector E, that is B minus AX cap, must be a null space, must be in the null space of A transpose. Means A transpose, it is column space. So it is just like understanding or using that statement in a reverse way. There we were writing that the orthogonal to the column space, the orthogonal vector to the column space is the left null space, and we are using this one for that statement is used for solving this least square kind of problems. So all vectors perpendicular to column space lie in the left null space. So this E must be in the null space of AT. That same condition, AT is the column space of A and it should be perpendicular to E, means A transpose, that E is nothing but B minus AX cap, it should be 0, or if we solve this equation we can write this one as AT B minus AX cap. We can write AX cap AT when we multiply these individually, and when we write them, so it is A transpose AX cap is equal to A transpose B, and the same is being shown here. Now here we have A's, and let's say this column A2 and the B it is, and P. The P is nothing but AX cap minus PB. We can see those later. The projection of this B, the projection of B means whenever this B is extended on the horizontal plane, then whatever is the length of that one, to that we are calling it as P, which is nothing but the projection of this P, which is AX cap minus PB. So A1 transpose E should be equal to 0, A2 transpose E should be equal to 0, and similarly A transpose E, which is nothing but A transpose B minus AX cap, should be equal to 0. Next one is the error vector must be perpendicular to each column, A1, A2, etc. How many are in A? Now here we have A1, A2, A3, let's say n number of this vectors are there. So this A's are up till A1 to An. So A1 B minus AX cap is equal to 0. Similarly A2, A3 multiplied by this is equal to 0, and last An B minus AX cap is equal to 0. Or we can write this one is a row space. So we can write this one as column space. In terms of column space, A1 transpose, A2 transpose, this all multiplied by B minus AX cap should be equal to 0. The same condition, whatever we have just seen here, the column space must be perpendicular to the left null space. The same we are saying. Now the thing is how to solve this one. The fastest way is to multiply the unsolvable equation x is equal to b by at. So we can solve this equation and we can get all these equivalent methods produce square coefficient matrix, that is A transpose A, when this AX minus B, AX is equal to B, is multiplied with A transpose. So A transpose A we are going to get. When AX is equal to B is inconsistent, its least squares solution minimizes, means AX is equal to B is but not solvable, then we are going to follow these all things. So AX minus B the whole square, the solution minimizes this errors. So normal solution would be A transpose A, X cap is equal to A transpose B. A transpose A is invertible exactly when column of A are linearly independent, and the best estimate of this would be X cap, that is the least square error. X cap is A transpose A, the inverse of this A transpose A, and A transpose B. The projection of B onto column space is nearest point AX cap. Projection P is equal to AX cap, that is equal to A into bracket A transpose A inverse A transpose B. Now here the projection is A X cap, that is equal, that is equal to PB. We'll understand this problem because these are the just equations we need to follow. The next one is this problem. Let's check out this example. Let A is equal to this 3 by 2 matrix and B is this one. And as we know, we get 3 equations out over here. So exactly 2 equations we get, but as per this matrix, let's say 3 equations are there and 2 unknowns are there. When 3 equations and 2 unknowns, then this equation becomes unsolvable, and as it becomes unsolvable, has no solution. And what gives the best solution? So the solution, if it is not possible, if it is inconsistent, then we are multiplying with A transpose as per that theory. So A transpose A we find. What is the transpose of this A? A transpose is where the columns are converted as rows. So 1, 2, 1, 3 and 0, 0. And A is as it is. When we multiply this, we are getting this 2, 5, 5, 13, a 2 by 2 matrix. Now what is the best, as per this, the best estimate means what should be the value of x to find that way? Here just we get A transpose A, x cap is equal to, so A transpose we have multiplied, but the further step has to be either Ax minus b the square, or it has to be find the value of x. So by this x cap, the value of x cap is when this A transpose A goes on this side, so certainly this equation is. So we have to solve this equation to get the values of those unknowns. Now let's use that. X cap is 80 A the inverse into A transpose B. Say 80 A the inverse A transpose B. So let's solve this. We have got the value of A transpose A. A transpose A is already with us, and its inverse is to be found. The inverse of a 2 by 2 matrix is obtained by exchanging the diagonal elements. As we know, this 13 is taken first and the 2 has been moved here, and changing the sign of the minor elements. So the diagonal elements are exchanged and the sign of this minor diagonal elements are changed. So after this is our A transpose A inverse, then A transpose is the same, and B is plus 4, 5, 6. And when we solve this, we may solve in any of the ways. So after solving this one, we'll get 2, 1. So what is P? Projection P. Projection P is equal to A x cap. So A x cap. A is this, x cap is this one. The value of x cap is 2, 1. So we get 4, 5, 0. Means the projection is Ax cap, and to find the projection we need to know the value of this x cap. They are the possible solutions, and the possible solutions are obtained by this x cap. Even this equation, it is this matrix, it is a 3 by 2, but as the last row is a 0, we have only 2 equations out of this. And when we solve this equation, let's say the first one is x1 and second one is x2. The unknowns are x1 and x2. When we solve this equation, it is x1 plus 2x2 is equal to 4, and the second one is this 1, that is x2 plus 3x2 is equal to, sorry, it has to be x1 is equal to 5. So then x1 is equal to 2 and x2 is equal to 1. Means the same values we get. Now this equation, now this method proves us, like this is a trial method, like it is by which we are checking, now by which we understood by trying, like we know the solution of this matrix is like x value is x1 is 2 and x2 is 1, and the same we have obtained by the least square methods. And this is the way how we solve by using this error method. Now the next one is like least square fitting data. The least square fitting of data, this is given by B is equal to C plus dt. The projection on 2 dimension gives C plus dt1 is equal to B1. So these are the different kind of another set of least square method problems. The projection on two dimension gives C plus dt1, C plus dt2, b2 and so on, C plus up till m. dtm is equal to bm. This is an well-determined system with m equations and the two unknowns, and the unknowns are C and D. The unknowns are C and D. If errors are present, it will have no solution. Otherwise, it will have a solution. So let's solve such kind of problems. So these equations, general form is always this first column is 1 and second one will be the values of t's which will be given in our problem, and C and D are unknowns, and B1, B2, B3 will be the values given as in the problem. Or it is just like Ax is equal to B kind of a solution. The best solutions means the best values of C and D are represented by C cap and D cap is the X cap that minimizes the squared error E square. Then what is E square? E square is equal to B minus Ax square, as we are already known with this. And this one, like B, for the first one when we expand, B is B1 for the first term minus Ax. Ax is, it is C and dt1. So it would be like minus sign will be there, that is minus C minus dt1 plus B2 minus C minus dt2. And this way it continues up till the last one, Bm minus C minus dtm, the square. The same E value, but as we are thinking of the magnitude of this, so Ax minus B can be written or B minus Ax. So we are using B minus Ax form there in finding those least square problems. Let's consider this problem wherein B is equal to 1, T at T minus 1, B is 1 at T is equal to plus 1 also, and B is equal to 3 at T is equal to 2. So for this, this matrix is written by considering, now general form of this equation is like 1, or the first column should be all ones. Now how many T's are there? 1, 2 and 3. So as 3 are there, we need to write 3 points. The value of our m is 3. And the first T1 is minus 1, T2. This is T2, second one corresponding, this one is B2. So 1 it is, and T3 is 2. And C and D are unknowns. And the values of B's at respective values of T's, first it is 1, second is also 1, and third one is 3. So 1, 1, 3. Now here when we go for solving this one, we get like the solutions like C minus D is equal to 1, and C plus D is equal to 1, and 1 plus 2 is equal to 3. These lead to the equations like C. Let's give the equations as C plus D is equal to 1, C minus T is equal to, this will give the solutions as C minus D is equal to, like this will give the equations as C minus D is equal to 1, C plus D is equal to 1, and C plus 2D is equal to 3. And here the solution becomes quite impossible. So in these cases, to find the solutions, we have to draw in this way. So let's draw the x and y two-dimensional system, wherein the horizontal axis is T and vertical one is B, and let's represent these 3 points. When we represent these points are like B is equal minus 1, 3 equations, minus 1, 1. Let's represent these points. So T1 is minus 1. So minus 1, 1 will be represented over here because this is 1. and 1 1 plus 1, and this on this right side at this place the dot, and 2 3 will be represented 2, t is 2 and 3 is the height, so which will be this dot. Now the solution would be in such a way that it should be a line. In C plus dt we are finding the line which will give us the least error points. So let's see, we need to draw a line over here, and which line we need to draw. So let's draw a line in this way, and what should be the slope of that one we need to calculate it. So let's draw a line, and this line is like, is it possible to join all these points on the same line? The answer is no. If it is possible, then certainly this equation becomes solvable, but it is not solvable. So we are drawing a line in such a way that we should have the values of these errors. Error is the distance between this line and B1, distance between the line and B2, this point, the distance between this point and this line, distance between the point and line should be minimized. Then let's draw such kind of a line, so that if we take the slope bit down, then this error would certainly, E2 would decrease, but E3 will increase. So for that, let's draw such kind of a line, and let's see what should be the further thing. So as Ax is equal to b cannot be solved by least to squares, by least to square methods, it is not solvable. So we need to go for A transpose Ax cap. Means if we can't solve the equation by least to squares, then what should be the process? The process is A transpose A x cap. So whatever is A, we find this method like A transpose A x cap. A transpose of this one is this, A the same one, x cap, C cap and G cap is equal to A transpose B. We need to find what is A transpose, and this B has to be multiplied to that. So we get A transpose A multiplication value as this, and x cap is this one, is equal to, and when we multiply this A transpose with B, we are getting this value. Now when after this, when we multiply, we'll get the best solution. The best solution is C cap is 9 by 7 and D cap is 4 by 7. How do we get this? So we solve this equation, linear equation, that is 3C cap plus 2 D cap is equal to 5 is first equation, and 2C cap plus 6D cap is equal to 6 is our second equation. So we solve these two linear equations, and then we'll get the values of, we know how to solve the two equations, and two unknowns are there, we can solve it. So we get the values of C cap and D cap and the best line. So this gives the value of our best line. Means how to draw this line, just we were drawing, but we were not knowing what should be the slope of this. So we are calculating it arbitrarily, no need to use the scale and draw this one, like how much will be the value. We draw arbitrarily the line and we'll go for finding what should be C and D. Now we know that C plus dt, y is equal to mx plus c is the line, where the m is nothing but slope of the line is d and c is the constant. So the line which will give us the best solution and which will have least errors is 9 by 7 plus 4 by 7 t, or it is 4 by 7 t plus 9 by 7. So equation of this line is so when t is equal to minus 1, its value is 5 by 7. When t is equal to 1, its value is 13 by 7. Like just we are putting the values of t in this equation, we are getting these values, the value taken by that line at these values of t's. And when we know the values taken by this line at different points, then the points, certainly these points are lying on the line. As these are lying on the line, the vector P, means we are getting the projection, the P vector. The P vector is 5 by 7, 13 by 7 and 17 by 7. It is the projection vector. And this vector is on the line. Now, as we know this point lying on the line, now the error we can find. The error is nothing but, now this the vertical errors are there, the horizontal errors are not there. So it is this value, whatever is this B1 and this, the difference between this B1 and this line point, that is 5 by 7. So we are finding the errors, the differences between the point and the line. The line points are already with us. So we go for finding the error is equal to B minus P. So the first one is B1 minus P1. So it is B1 is 1. B1 is 1. We are given with 1. So B1 minus P1. So it is 1 minus P1 is 5 by 7. We'll get 2 by 7. Similarly E2 and E3. Now 2 by 7 minus 6 by 7 and 4 by 7. From this we'll get to know it is, this error is 2 by 7 and this one is minus 6 by 7 and this error is 4 by 7. And this error vector is certainly orthogonal to left null space. So left null space means this is our error vector, and when it is multiplied with our C plus GT matrix, we are getting 0, means it is our left null space. We had only 3 points. When we have more number of points, then the calculation, like solving of this equation, finding A transpose A, and all would be a bit complex. So in those cases, we are writing this A transpose A, that is C cap D cap, is equal to A transpose B. This A transpose A is obtained as it is yum. Yum means the number of points, like how many we are given, like T1, T2, B1, B2, the number of M's. If there it was B1, B2, B3, up till B3 it was, so it was 3 in the last case, and T1, T2 till T3, it would be this number. So sum of all these Ti's would be the second term here in that row, and sum of all these Ti's would be, again, will be there in the first columns, and the sum of this Ti square will be this element. So we can find in that way, and even we can go for finding this, and these would be that A transpose B is nothing but summation of Bi and summation of Ti Bi. By using this also we can find. The next point in the weighted squares is nothing but, the next point is weighted least squares. In least squares we had given the same weightage for both of them. Now for example, if two values are there, so this will give us x is equal to b1 and x is equal to b2. So e square is equal to x minus b1 I have written, and x minus b2. And here the best value of x is b1 plus b2 by 2. But suppose if the importance, like now suppose two observations are not trusted to be the same degree, the value x is equal to b1 may be obtained from more accurate scale. If b2 contains some information, we are not willing to rely on b1. The simplest way means, here b1, if we write in this way, b1 and b2 are having the equal weightage. But if we want to rely on one and we want to give bit less importance to the other, or in vice versa, then even we can go for assigning the values, like how much percent of this b1 and how much percent of this b2 we are going to rely on. And in those cases, the simplest way is to attach the weights. Let's say W1 is the weight of this B1 and W2 is the weight of this B2. When we attach those, then this E square will become in this way. And if we think that W1 is having more weight than that of W2, means the importance is given to W1, means B1 first. The more importance is there on B1. And when we square it, when we differentiate it, when differentiation of this gives us 0, that would be our best point as per the previous knowledge. So the differentiation of this one will give us this result. So here x cap, the best solution itself, but in terms of weights it is. So we attach, we write it as wx, w the cap. So it is w1 square b1, the weights get attached, and even in place of 2, it would be w1 square and w2 square. And in this equation, if w1 and w2 are same, then this is nothing but b1 plus b2 divided by 2. xw is the weighted average of the data, and this average is closer to b1. So this average would be closer to b1 than b2. The least squares would be, the least square solutions have to be in terms of w. It is not just x is equal to b, it is w ax is equal to wb. And the normal equation would be A transpose W transpose WA, just like A transpose A we need to write. So here it would be the W transpose also in these equations, and the same here on the right side, that is A transpose B, wherein W and W transpose also come. If x is equal to Wx and y is equal to Wy, we write Y transpose x is equal to Wy transpose Wx is equal to 0. These have to be followed if the weighted values of our B1 and B2 are given. Weights are assigned with our values.